Welcome back, students. This is another module on arrays. We have already discussed about how to deal with one-dimensional arrays. Now we will go ahead and learn how to deal with two-dimensional arrays. Actually, in C there is no limit to the number of dimensions of arrays that you can have, but usually we will stop at 3. But of course, in the course of this particular module, I will introduce to you to dimensions 2, and later of course you can go ahead and try with more dimensions also. As part of this module, we would be learning about these 3 things here. By the end of this module, we should be able to know how to declare and initialize two-dimensional arrays, and we will take an example of the addition of matrices again from mathematics. We all know how to carry out matrix addition. That problem we will try to write a program which actually given two matrices will find out the sum of the two matrices and put that result in a third matrix. So we will take that example which will help us to understand how to read values into an array, how to manipulate the values, so on and so forth. And also finally, like we have seen in one-dimensional arrays, two-dimensional arrays can also be sent as function arguments to a function. Because in general we write programs and we break it up into small functions. We have a main function, we have several number of main functions, smaller functions, wherein one function calls the other and the communication takes place between the functions via the arguments. So arrays can also be sent as arguments to functions. That aspect also we will examine. Now let us try to understand how these two-dimensional arrays work. And we have to be able to visualize certain things in order to understand exactly how the memory allocation takes place. We are familiar with this matrix notation from our matrix algebra. You can see that it is a 3 by 4 matrix. That is, they have 3 rows and we have 4 columns. And if the same thing, if it has to be stored in our computer, if you want to handle a matrix like this, obviously we need to have some kind of an arrangement of memory which can reflect this kind of an arrangement, and the two-dimensional array does exactly that. For example, this is how you declare a two-dimensional array. Contrast that with what we have declared earlier. This is a one-dimensional array. You see one set of square brackets is there, whereas here you have 2 set of square brackets. One specifies the number of rows, the second dimension specifies the number of columns. If this kind of a declaration is made in your program, you can just visualize that this kind of a memory is going to be allotted. This is just for visualization. Actually inside the computer it is not going to be like this, but for the purpose of our understanding, let us for now think that this kind of a declaration will result in this kind of a memory allocation where each box can store a single integer. Now, as all of you know, how do we address the individual cells? Earlier in one-dimensional case, one index was sufficient. But now, if I want to address this cell, as all of us know, that has to be specified with the intersection of the number of row and the column number. That is row 1, column 2. So, if the name of this array is A, this would be referred to as name of the array, column number, row number is 1, column number is. So in it's very simple. In two-dimensional array, we need to specify 2 dimensions, 2 indices in order to access a single cell or element, unlike in one dimensions where we use only 1. That is the only difference. Now as if this has been allocated with this kind of a statement, obviously what we need to do here is, we know in matrices we start with 1 like this, but in C programming, when a two-dimensional array is allocated like that, always our row numbers and column numbers, they start from 0 and they end with one number less than the size for obvious reasons. So if there are 3 rows, the rows would be 0th row, first and second row. So is the case with columns. Obviously the 3 value here, if it is stored here, it will correspondingly get into 0 0, that is A 0 0. Same way 4 will get in here, 1 will store here, 5 we will store here. Likewise 1, 2, the storing of values inside the two-dimensional array corresponding to this matrix would be like this. Obviously there is some change in indexing because in our mathematics we start with 1, the indices, but in C we start with 0. According to that, the location of the element has to be accessed. You can see the declaration and initialization here. It's 2-dimensional array, so we need to provide, as you see here, 2 rows and 3 columns, and this is how we provide. This is first row, second row, 2 rows, and within each row we have 3 elements. So obviously these things will be assigned to the 2 by 3 matrix like this, 2 rows, that will get into 1 here, 3, 5, that gets in here like this. Where is 0, 1, 0, 1. So if you want to access this element, it would be A of 1 and 2. So this is how you initialize. Same kind of rules that we have already learnt for about one-dimensional arrays also pertain to here. So with regards to the syntax, I think you can refer to any book and find out how to declare these things. There is not much logic to it. So you can refer to any proper textbook and find out how these initializations can be carried out, but you must know it. Let us now look at the problem of matrix addition. For example, let us take 2 matrices. Obviously, for addition to take place, we know the rules. Both matrices must be of the same size. Let us assume that they are of the same size. They are both are of 2 by 3 size. If you want to add the 2 matrices, we all know now the corresponding elements have to be added together. If this is matrix A and if this is matrix B, corresponding members mean 3 and 4. That is A. So this is 0, 1, 2. This is 0. That is how the indexing go. So this would be A of 0, 0. That should be added to B 0, 0. That is 4. So corresponding elements must be added. We already know that. And that has to be again put into a third matrix of the same size. And of course 3 plus 4. The resulting matrix after adding these 2 matrices would look like this. That's a very simple thing. All of us can very easily understand that. Now the same process, whatever we have just done, now has to be carried out by a program. Now we have to write a C program which does this. That is, given any 2 matrices of the same size, it must be able to carry out the addition and put the resulting matrix into a third matrix. Just like we have done it for one-dimensional case, same thing let us do it for a 2-dimensional matrix. Now I want you to consider this program partially written again. We will complete as we go along. Normal hash include. I want you to notice that I have declared 3 arrays of size 2, 3, that is 2 rows and 3 columns. All of them are of size 2, 3. All are 2-dimensional arrays because the problem at hand warrants me to declare a 2-dimensional array. As a programmer, you must be able to judge and know when to use a 2-dimensional array, when to use a 1-dimensional array. With experience, it becomes clear very, very quickly. Done that. I have declared 2 integer variables here, and I want you to right away notice that I am using 2 for loops here. Whenever you are using and dealing with arrays, the number of for loops depends upon the number of dimensions that you have in the array. If you have a 1-dimensional array, single for loop is sufficient. If you have 2-dimensional array, you need to have 2 for loops because 1 for loop to iterate through each dimension. So for every dimension we have a for loop. So you can see that there are 2 nested for loops. There is one for loop within another. This is the outer for loop. This is the inner for loop. Let us quickly try to go through the values. How, as you see here, there is only one single statement in the for loop, scanf statement. Now if I ask you the question, how many times the scanf statement is going to be executed? It is simply 2 into 3, 6 times, because the outer loop goes through 2 times. Inner loop, for every outer loop, the inner loop goes through 3 times. So 2 into 3. Scanf gets executed 6 times. And what are those 6 times? For every one of those 6 times, I and j will be different, and it will go through like that. First iteration, I want you to see where the value will be stored. That is, I want you to look at when the first time scanf is executed, what is the value in I, what is the value in j. For example, my inputs are like this. Some values let us assume again. Let us say my first matrix is like this. Let us say this is my first matrix. This has to be stored into, let us call this as the this. So let us see if these are the values are type, into which one of these cells 9 will go, where 2 will go. First time it is executed, what is the value in I and j? As you can see here, first time when the loop is entered, the value of I is equal to 0. It tests this, it's not false, so it comes in. And once for one value of 0, I, this inner loop will go through j is equal to 0, j is equal to 1, j is equal to 2. So this inner loop will finish first. That is, for a given value of I is equal to 0, j will go through 0, 1 and 2. Again I becomes 1. For I is equal to 1 also, j will loop through 0, 1 and 2. That is, first time it is executed, it will be 0, 0. Second time it will be 0, 1. Third time it will be 0, 2. Then once after that, I gets incremented, I begins with 1. And again j freshly starts from 0. So 1, 0, 1, 1, 1, 2. So you can see that 0, 0 first, 0, 1 next, 0, 2, 1, 0, 1, 1 and 1, 2. So the values here would automatically get into 9 gets here, 2 gets here, C gets here, 6 gets here, 3 here, 1 here, 5 here. So here the only thing that you have to understand is how these things work. And I want you to notice the condition here and here. This controls the columns, the inner loop, the outer loop controls rows. And again, how to write, whether this should be outside or this should be inside, totally depends on the programmer, how he wants to do it. If you write like this, you are going to read row wise. I want you to think of, if I want to read it column wise, how we should change this program. I want you to think about it. So it is all in the hands of the programmer. There are no set rules. It all depends on what you want the program to do. According to that, you write your program. But the way I have written right now, I have the rows in the outer loop, columns in the inner loop. If I write like that, obviously the columns will change much faster. So I will be going like that. Once I finish, come back, go like that. So row wise. So once I type my values like this in the keyboard in that order, automatically that will get into. So apart from this, there is hardly anything different, whether it is 2 dimensions, 3 dimensions. If it is 3 dimensions, you will be using 3 for loops, 4 for loops, so on and so forth. But at the bottom most, you are just dealing with integers, nothing more than that. Only to get to an integer, you are using more dimensions. And this is the notation. Look at the for loops. 2 dimensions means you have to use 2 for loops. Be very careful about what you are writing here. As I said, rows in the outer column right now. Columns I have written here, that's why. See the number 2 here, which is the number of rows. See the number 3 here, which is the number of columns. And ampersand, this is the notation. Be very careful. Same code be repeated, because this loop, 2 loops here, read only values into one matrix, which is A. Same set of statements starting from printf. Now we can say enter second matrix. Read the values. I will write the code. As you can see, same set of lines are repeated, only difference is here. Earlier it was A, now it is B. So this code will read values into the second matrix. So you have put your first matrix into A array, second matrix now you have put into array B. What is the next step that is remaining? We just need to carry out the addition process. Again, in that addition process also we have to access all the elements of the arrays in 2 dimensions. So again we need 2 more loops, so that we can access element by element from the 2 matrices, add them and put it into the third matrix. The code I am going to write now. You can now see the code here, which carries out the addition of the corresponding elements of the 2-dimensional matrices. As you can see here, loops are all exactly the same, but now the statement has been altered, which will obviously carry out Aij plus Bij added together and put it into Cij. So it will be C00 is equal to A00 plus B00, C01 is equal to A01 plus B01, C02 is equal to A02 plus B02, like that. That will finish the inner loop, comes back, then C10 is equal to A10 plus so on and so forth. Just visualize that, how the inner loop finishes, then it goes back to the outer loop, then I is incremented. For that value of I, again the j loop totally execute starting from 0. So that way, row wise you are going to process the elements of each array. So this just carries out the addition of the 2 matrices. That's it. Only one step is left. We want to see the result. So how do? We simply print out the values in the third matrix, which is C, the result matrix. And how do we print? Just like we have scanned, same set of for loops, but instead of scanf, we are going to use printf statement. As simple as that. So the last piece of code, which is this, will simply print out the values in Cij, again 2 loops, exactly the same loops, but only thing is, I just want to warn you, the output is not going to look very pretty in the matrix form. I want you to think about how to actually print it in the matrix form. It's just going to print out the values correctly, but it's not going to be in the form like this. All will be printed in the same line. That's a very small matter, nothing to do with arrays, just think about it. And of course that ends the program. So as you have seen, there is hardly any difference between how you deal with one dimensional array or two. It's ultimately just adding 2 integers, nothing more than that. But in one case we are only dealing with one dimension, so there is only single for loop, because in order to get to the element, one index was sufficient. Now in order to get to the element, you have to specify I as well as j. So we need one for loop for I, one for loop for j. So nested, that's how we use. Apart from that, almost the idea is not different at all. So simply this example must tell you how to actually declare, nothing difficult. How to read values, again no different, only 2 dimensions are there, ampersand, scanf, everything is the same as you have seen. And carrying out the operations on individual elements, we have to always take the 2 indices, they have to be iterated upon just like before. And printing, again nothing different at all. Only thing is you have to get used to writing the 2 for loops, know which one is in the outer for loop, know which one is in the inner for loop. In general, we put the rows in the outer for loop, like here we put the columns in the inner for loop. Some special cases, depending on the problem that you are solving, you may want to change the order, you may want to read column wise than row wise. That is totally up to you. You think about it, how you can actually carry it out. One simple general concept I would like to introduce to you right now, in general how people work. When you declare an array, you have to give the sizes. It could be something like this, 6 and 8. What does that mean? This will simply allocate in the computer something like this. You can visualize it like that. It has 6 rows and 8 columns, as you can see it. So what this actually means is, this total space has been reserved for you. It doesn't really mean that you have to use up all the space. Usually what we end up doing is, we allocate like that, but most of the times we may just end up using only part of the, that is meaning 3 by 1, 2, 3, 4, 5. So you may be using, so what is utilized is only a partial or only part of the total array that has been declared like this. So when you want to do that, obviously in your loops, you can't be using 6 and 8, because only we are using 3 rows and 5 columns. So in general, how we deal with this is, we allocate like this, all right, but for the specific problem, the sizes could be vary. One time it could be 3 by 5, another time it could be 4 by 5, another time it could be 4 by 6, another time it could be 2 by 8, so on and so forth. So how do we keep track? For that, we generally make use of 2 more variables. We can call that as rows and columns. So in this particular case, rows would be set to 3, columns would be set to 5. And for your for loops, you will write something like this. For I is equal to 0, I less than rows, I plus plus, inside j is equal to 0, j less than columns, j plus plus. This is how we generally write the code. We don't put numbers here. That's not a good practice. Only because it is a starting problem, I just fixed everything so that we understand how things work. But in general, this is how we write. We allocate with some fixed numbers, but we always, because from problem to problem the sizes will be different, so that we want to keep track of the size. For that we need 2 more variables, rows and columns. In this case, rows may be set to 3 in this particular case, and columns will be set to 5. Another time you run this program, this could be totally different. This could be 4 and this could be 6. Another time you run it, this could be 3, this could be 4, whatever. I hope you understand. So this is how we keep track of things. So next we are going to look at how to actually use these 2-dimensional arrays as arguments to functions. It's going to be almost identical to what we have done in 1-dimensional arrays, except that a couple of things that are going to be. I want you to now look at this partially written code again, which we are going to finish. Again, starting from this, I just want you to immediately look at these 3 lines here. Like before, I have split up the code. My intention is that I want to organize my entire code in the previous example into 1 or 2 parts. 4 functions, one main function and 3 functions, which are read matrix, add matrix and print matrix. The names themselves must tell us what actual function they are going to carry out. Read matrix is going to put values into a matrix, given a matrix and the size of rows and columns. Add matrix, given 3 matrices or arrays and the number of rows and number of columns, it is going to add the 2 matrices A and B and put it into C. On the other hand, print matrix, given one matrix array and number of rows and number of columns, it is going to print it on the screen. I want you to notice one thing here is that the column size is a must, whereas the first dimension you can leave out as blank. The later dimensions, if it is 3 dimensions, the next 2 are a must. If 4, next 3. Only the first dimension is, you can leave it as empty. You don't have to really discuss too much about it right now, but just for your curiosity's sake, I can tell you that in order to compute the address of an element in more than one dimensions, we need to know the size of the column. Unless if you know the size of the column, we can't know when the next row is starting, because in reality, in the computer, all rows are actually stored one after the other, not like you visualize like rows and columns. So in order to, when it is everything is lined out like that, you have to know when first row is ending, next row is starting. For that, we need to know how many columns are there in each row. That is the reason why only the first one is optional, but the rest of the dimensions must be provided where you have dimensions more than 1. That is the only thing that is different here. Apart from that, all the logic, everything is the same. As you can see here the main function is very simple code. It just asks for the number of rows and columns. Once you put in anything for that matter, of course we have to declare the arrays also here. You can see that in the first line I have declared 3 arrays, 2-dimensional arrays, size rows and size columns both I have given as 10 and 10 for all the 3, and number of rows and columns. As I already mentioned, the maximum size available to me is 10 by 10, and I could be using any matrix of size which is less than or equal to size 10 by 10. And what the size of the matrix currently being used, that will be specified by the number of rows and columns which are given as input to the program, which I am reading using this scanf statement. Once we have read the rows and columns, it's a matter of simply calling the functions and getting the job done. And the main function simply goes on calling read matrix twice, once for A, once for B, then add matrix, then print matrix. As you can see, the finished main function. Still we need to write the 3 function bodies later. As you can see here, this main function does very little. It just declares the 3 arrays, it decides what is the number of rows and columns, and simply goes on making a sequence of function calls. First it calls the read matrix twice, once to read A, another time to read B. Next it simply gives those A and B and C to another function called add matrix A, B, C. Look at again the arguments. There are no square brackets, no sizes, no data type. Simply the name of the arrays, nothing else. A, comma B, comma C, which are nothing but the names of the arrays everywhere. So whenever, how do you pass an array as an argument to a function? It is simply by using the name, nothing else in the function call. Prototypes you have to give everything, but in a function call only the name of the array. So this is how you go on making a sequence of function calls, and the job is done in the main function. Still we need to write the functions. Here I am just going to write only 1 out of the 3. I think the rest I will leave it to you. It should be very easy for you to complete the other 2 functions, because the syntax is going to be almost identical, and it must be quite easy for you to simply finish the rest of the functions. You can see the code of one of the functions, which is the read matrix, like this. I just want you to notice here, because the point of discussion here is arrays as arguments. You have to see how the array has been received as an argument here. First you can see that there are 3 arguments. This is the array. Next argument is a normal integer int r, where r is the number of rows which has been passed from here, and int c, where c is the number of columns received from the function call. So 3 arguments. First one is the 2-dimensional array. Here you have to notice that I have given the size. The second dimension has to have a size. First dimension it is optional, whether even if you give it, it is ignored, but the next dimension you have to give the size. So this is what you have to distinguish between what you have done before and now. Apart from that, 3 arguments, one for rows, one for columns in the actual array into which the values have to be read. And once you come to the code, you can see I have declared I and j because now I have to iterate through 2 dimensions. So I will use I for the rows, j for the columns. And you have 2 for loops here. Outer for loop, as you see here, R is controlling that is the number of rows. Inner for loop, you can see C is controlling. C is nothing but the number of columns. I have used I to go from 0 to the number of 1 less than R here. J I have used for columns. It will go from 0 to 1 less than C, as you already understand. So it will just loop through. You know how the loop works. As it loops through, it will fill up all the values in the array row wise. Once it is done, it gets back to the function. So main function will simply call this function twice. By doing that, first time A is filled up, second time B is filled up, third function call I have not written here. I want you to write it. Already the code I have given, just put it into the function form. Nothing more than that. Just remembering this aspect. Just finish the 2 functions. Obviously this main function is complete with these 2 read calls, one addition add matrix call, one print matrix call. Your function, your program should work without any problems. So this is how you actually deal with 2. So whether it is 2 dimensions, 3 dimensions, 4 dimensions, it's hardly going to matter. At the bottom of the thing, you are just dealing with integers or floats or chars which are put into the arrays. Only thing is you would require more and more for loops. If you have 3 dimensions, you will require 3 for loops. 2 dimensions, 2 for loops. 1 dimension, 1 for loop. 5 dimensions, 5 for loops. So this is as simple or as difficult as it is. And depending on the situation, you as a programmer have to choose what dimension array do I need for the situation. So with that, I think you have understood how to deal with arrays. It's just an arrangement, nothing more than that. Instead of having one array, you have several, one integer value or one float value, have several integer values arranged maybe in just a row, which is a 1-dimensional matrix, arranged as a table or arranged as a cube, so on and so forth. Only the arrangement is different. So if you can understand that much, I'm sure you will be able to easily deal with arrays. Thank you.